Greetings, programs. Welcome back to Stegosaurus Studios. This is episode 21. It's been a very long time since I published episode 20. There's probably lots of reasons for that, but you don't really want to hear any of those reasons. So let's move on. Tell you what, why don't we go out to the barbecue island and we'll do an update on the frame out there. Okay, follow me. All right, thanks for following me out here. So let's start at the front. So a couple of things. This plastic part, so the air spring connects into this. So I need to make that in aluminum. I still haven't done it. And that means I don't have any air put into the air spring. So on the front end anyway, I can't really demonstrate. There's like a little bit of movement, but not very much because there's no air in it. So since we're talking about movement, so this from 80/20, this is a pivot joint or pivot nub, they call it. So it's got the nub that attaches to the aluminum extrusion, and it has a sort of the pivot axle right here, and then two arms that go up, and then they are attached to another piece of extrusion. So sometimes when you put these together, depending on your construction, when you tighten these screws down, it pinches the axle back here, and it makes it really hard to move. So they actually supply these. This is like 15 or 20 little very, very thin shims. They're all stuck together, and you peel off as many as you need, and then you slide them in here to keep that, instead of having it turn in and get pinched, to keep it straight. So very useful. They work actually pretty good. My warning for you is don't put the whole thing together and then think you're gonna get these shims in afterward. I did that on the back end and ended up taking like most of the back end apart. So put the shims in while you're doing it. Actually, along those same lines, when you're putting together really any project, but when you're putting a robot together like this, don't put Loctite on the nuts and put lock nuts on the very first time you're putting it together, because I guarantee you're going to take it apart. I've taken everything on this thing apart already. I'm probably going to do it a bunch more times before it's all said and done. So yeah, don't do that. All right, let's go back to the back end back here. I don't know if I'm going to be able to get far enough away because I need to, so we'll just go look at one side. So this thing's really heavy. So here's the shock action. And of course it's not working for me. So, all right. It actually has pretty, even though same thing on here, these air springs don't have any air in them yet because the block that it screws into is still plastic, and I don't have those made. But when you lift the frame up, if you have two arms, because I'm trying to do this with one, you can actually see the shock action working, which is good. So what's missing in the back is the steering motor, and then the connection. So this is the rack and pinion. So this is basically the slider, and this thing moves back and forth on it. So there's a connection from here to this hole in the steering arm. So this steering arm is what rotates this thing back and forth, and I don't have that connection made. And of course I just got this silly thing in, and I'm not gonna be able to get it back in. But so this block right here, what this is, it's meant to hold this, the wheel moves, but it holds it in place, and it actually serves two purposes. One, it's for testing purposes, it's going to hold the wheel at a known zero position, so that when you actually start moving the wheel to make it turn, you'll know where 0 is. Long term, we're going to put in an auto calibration. So on startup, it'll automatically go rotate and find the calibration point, and then that will 0 the system. But for right now, for rudimentary purposes, for testing, I just have these 3D printed blocks that'll hold it in the 0 position. The other thing that they're useful for is if you need to push the droid. If this isn't here, and you go to push it, the wheel turns like that, and it's not going to push in a straight line. So the block, right here, will stop it from turning, and allow you to push it. So let's see. I think that's the status on this. Like I said, on the rear, it's just the steering connections and the steering motors. I just have to fabricate one aluminum piece, which I can do that myself, and then I have everything to mount the Neos and then start wiring. And then on the front, I'm very close to having the steering motor identified for how that's going to steer, and just need to buy it and buy the connecting components, and then the front end will be done. I'm also going to go to Tap Plastics and get some sheets of plastic that will go down in here. So basically, get down at this end, this whole inside will have a plastic bottom, and that's where all the electronics and everything will be harbored. The batteries, the amplifier, everything will sit right in the middle of the frame. And then of course on the outside will be the 3D printed and painted body panels, and the pit droid sitting up on top of it and everything. So making good progress. I actually have a video which I've already recorded, but it's coming up in this episode where I've done some benchtop testing for the steering motor. So like I said, those are ready to go in. That's the status. All right, so I'm out here. It's a breezy Mofeezy day, so hopefully there's not too much wind noise. So got the frame moved out into the grass, and there's a reason for that. And I want to understand the torque that's required to turn the front motor, or the front steering wheel. And so I've got a torque wrench, and I have this fitting that goes on to the shaft of the front wheel. And hopefully it's on tight enough to where it won't spin. I'm gonna use my torque wrench, put it in there, and then measure. And then to simulate, I have no idea what the rest of the frame is, and body panels and batteries and motors and everything else that still needs to go on here. So we've got 25 and 215, so 55, 55 pounds extra. It's almost bottoming out in the front, but this should be a pretty good test. So hopefully I'll get some measurements, good measurements, and we'll understand the torque required. I think this is a worst case on this grass. Smooth convention floor should be much easier. Asphalt, a little less so. So I wanted it to be able to handle, I'm not going to be driving on grass probably, but the asphalt, for example, at Maker Faire in the Bay Area is really bad. So anyway, I'm not going to record the whole, me doing all the measurements, because that's going to bore you, but I'll report back what I find out. Okay. All right, we have here just a messy test. So this isn't supposed to be pretty at all. So I have the Neo motor hooked up to the SparkMax controller, and then hooked up to a battery. I've got the receiver here hooked up to a 5-volt buck step down, and then I've got the radio. So this is just initial testing of the Neo in position control, which I haven't, sorry, I'm moving things around here. I hadn't done any testing of this yet, and so this was kind of the first test. So I have not done, I've done almost no PID loop tuning, so those parameters will need to change. But if you watch the the Neo over there, while I moved this back and forth, you can see that it is doing position control back and forth. So without the correct tuning parameters, it's really rough. It's not like when I go back to center, it doesn't have enough impetus because there's no integral or derivative to move it back to center. But anyway, this is the conceptual. So it looks like it should work, just with a lot more tuning. All right, so circling back on the torque measurement. So I did get some measurements. So my torque wrench is one of those, call it a brake style. So it's got a hinge, and when the torque exceeds the brake point, it breaks. Doesn't actually break, but the hinge moves. So basically, I turned it, this way and that way, and a bunch of times, and kept increasing the torque on the torque wrench until basically I could rotate it without the wrench breaking, and that measurement was 26.8 inch-pounds. So that's a good number, because the motor that I'm using is more than that, so it should be able to turn the thing on grass or pavement or pretty much anything, I hope. So I'm going to end the episode here. Next episode, maybe a miracle will happen, and I'll actually have footage of the frame driving around. So just got to get the steering motors on, get the front steering motor ordered, and get it on, and then do all the tuning and start driving it. So my long-term goal, not long-term, so I have an intermediate goal, which is to get the robot driving by Maker Faire. So Maker Faire is in September in the Bay Area, and late September, and so I'm hoping I will have it driving, preferably with the seat mounted on it. I probably won't put the pit droid on it. Might have a different passenger, we'll see. So anyway, that's the goal, and touch wood, we get there. So that's it. Thanks for tuning in. Talk to you later.